So recently there has been a group of people called the Flat Earth Society, and they're trying to prove that the Earth is flat. So today, I'm going to prove that the Earth is not flat. The Earth is round. Okay, so this is what the Flat Earth Society thinks the Earth looks like. It's a circular disc with the North Pole is in the middle, and Antarctica is a giant wall of ice around the edge of the Earth. And so this is North Pole, this is South Pole, or South Ice Wall. And this is the equator. It's just a circle in the mid that's like halfway between the North Pole and the South Ice Wall thing. Anyway, so this is the equator, and the sun is above the equator. And that's why the equator is so much hotter than the poles, because it's closer to the sun. And the sun isn't super high above the Earth, it's actually really close to the Earth, which is why moving to the North Pole or to the South Pole has such an effect on the temperature, because it's actually really close and really small. And the sun moves over the equator, around the equator, which is why the day-night cycle happens. So here it's daytime because it's closer to the sun, but on the other side of the Earth it's nighttime because it's too far away from the sun to see it. And at first this model makes sense, but then when you think about it, it really doesn't make sense. Because let's say someone is standing right here. There's no reason why they shouldn't be able to see the sun, because there's nothing obstructing their view. There's nothing between them and the sun. Of course, if there's clouds, they wouldn't be able to see the sun, but if it's a clear day, they should be able to see the sun. But you could say, oh, it's too far away for them to see. That's why they can't see it. There's nothing obstructing it, it's just too far away. Well, let's say there's another person standing here. They can see the sun because it's daytime, right? But then the sun moves to over here. And now the sun's over here. Now they can't see the sun anymore. But that doesn't make sense, because when the sun goes away and it's nighttime, you see this. You see the sunset. The sun goes down below the horizon. But at no point in this model does the sun go below the horizon. The sun goes above the horizon, and it's always in the sky. And this person should never see the sun go below the horizon. What he should see is the sun in the sky getting farther away, getting smaller, and getting dimmer until you can't see it anymore and it's nighttime. But that's not what happens. We always see the sun go below the horizon. So this model does not explain the sunrise and the sunset in a way that makes sense. It gives an explanation for how this day-night cycle works that doesn't line up with what we see every day. So this model is trash. It doesn't work. In fact, no flat Earth model, no model that shows the Earth as a flat disk will be able to explain the sunrise and the sunset. So, let's say this is the Earth from a side view. It's a disk. When we see the sunset, the only reason why we'd see the sun setting is because the sun would be going below the Earth, below the horizon, like down here. But if the sun goes below the Earth, nobody on the surface of the Earth will be able to see the sun, because the sun's below the Earth. But that's not what happens, because if you're in India and it's daytime and you call someone in America, the person in America will be seeing nighttime. If you're seeing daytime, they see nighttime. If you're seeing nighttime, they'll see daytime, because you're on opposite sides of the world. So the flat Earth model will never explain the day-night cycle and the sunrise and the sunset, because it's impossible, because the Earth isn't flat, the Earth is round. The round Earth model has no problem explaining these phenomena. This is the Earth, and the sun is over here. It's really far away. And the sun is able to light up this side of the Earth, and this side of the Earth is dark because this side of the Earth is blocking the sunlight from reaching this side of the Earth. And when you're on this side of the Earth, it's daytime, until the Earth rotates and you're on this side of the Earth. Then it's nighttime because now you can't see the sun because the Earth is blocking it. And when you see the sunset, that's just the point where the Earth is only partially blocking the sun. Here's the horizon, and here's the sun halfway blocked by the horizon. So the round Earth model has no problem explaining this. But the flat Earth model is completely incapable of doing it. So if you have the choice between the flat Earth model and the round Earth model, you choose the one that explains natural phenomena the best. And the round Earth model is easily the one that does that. Another thing that the Flat Earth Society cannot explain with their Flat Earth model is the stars. So, say this is the Earth, and I'm standing here on the Earth. Now, the stars are just scattered around in the night sky. Now, all of these stars that are around me, I'm able to see them. I can see all of them. There's nothing in the way of me seeing them. And that's what happens because I can, no matter which direction I look in the night sky, I see stars. There's nothing blocking the stars, unless there's clouds. But if there's a clear day, I can see stars all over the night sky. There's nothing that's blocking my view of the stars, unless there's the moon. But if there's no moon, then I can see the stars. And let's say there's someone else here. He can see all the stars too. His situation is no different than mine. He can see the stars too. And I can see, let's say, the Big Dipper or the Small Dipper, the Little Dipper. So can he. And no matter where either of us is standing, we can both see the Big Dipper. Like, say, the Big Dipper is here. This is the Big Dipper. No matter where you're standing on the Earth, you're able to see that. But that's not what happens. People in the southern hemisphere, or like far enough south, cannot see the Big Dipper. Because for some reason they just can't see it. They can't see the Big Dipper. And that doesn't line up with this model. So this model can't work because then everybody on Earth would be able to see the Big Dipper, while people in the south can't see the Big Dipper. And if you look at the globe Earth model, and let's say stars are all around the globe, and the Big Dipper's here, so this is the Big Dipper. I can be standing here, and I can see the Big Dipper, but this guy's standing down here, and he can't see it. And that's what happens. People who are far enough south can't see stars that people in the north can see. So, again, we have the Flat Earth model failing to explain a natural phenomenon that the globe Earth model has no problem explaining. So, clearly, the Earth is a globe, and it's not flat. Another thing that the Flat Earth Society cannot explain is the moon. Now, the interesting thing about the moon is we always see the same side of it. No matter what time of day or time of night it is, or what day of the year it is, we always see the same side of the moon. Now, parts of it are usually covered in a shadow because of the sun only lights up part of the moon, but the part that's facing us, the side that's facing us, is always the same. And the reason that is because the moon is so far away that no matter where you are on Earth, you always see it from the same angle. Now, the angle's slightly different, but it's so small that you don't notice it. And the way the globe Earth model explains this is the moon is rotating in a way that one side of it is always facing Earth. So this side is always facing Earth, but this side is never facing Earth because it just rotates in that way. And when you try to explain this with the Flat Earth model, it doesn't work out. So, let's just use a new sheet of paper. So this disk is the Earth. All right, so the moon is really high up. That's why no matter where we are on the Earth, we always see it the exact same. There's only a minuscule difference. So it's really high up here. So someone standing here and someone standing here should see the moon at the same angle in the sky. Now, it's a slightly different angle, but because the moon is so high up, we can't see the difference because it's so far away. But that's not what happens, because people standing on different parts of the Earth see the moon from different angles. So this guy should be seeing it like maybe straight up, and this guy should be seeing it straight up as well, but maybe he sees it sort of diagonal like that. And that would be easily explained if maybe the moon was really low down, but it's not low down, it's really high up. Because if it was really low down, this guy would see this side of the moon. Well, this guy sees this side of the moon. And we wouldn't all see the same side of the moon. So the moon has to be very far away, but then it also has to be very close to us as well. And that doesn't make any sense. And when you look to the globe Earth model, it does make sense. Because these people aren't only on different areas of the globe, they're also looking in different directions. That's why the moon appears in different areas in the sky. So, here's the Earth, and the moon is really high up this way. This guy sees the moon right above him. And this guy sees the moon to the side of him. So that's why people on different areas of the Earth see the moon from different angles, even though the moon is really far away. So the Earth has to be round because we have to be looking in different directions to see the moon from different angles. Because the moon can't be really close to us because we always see the same side of it. So the world has to be round. It can't be a disc. It has to be round.